Hey students, this is lesson 10.7, area of circles and sectors. So we're going to figure out how to find the area of circles and parts of circles. Go ahead and do this review. You can check back with your answers. All right, so here's our area of circle theorem we're going to use. The area of a circle is product of pi and the square of the radius. So if the radius is 5, then the area is pi times 5 times 5. If the diameter is 1.8, then the area is pi times 0.9 times 0.9. So the area of a circular ice skating rink, and we can leave that in terms of pi or not. If the diameter is 48, then that means the radius is 24. So we're going to do pi times the radius squared, so pi times 24 squared, which is, so we just have to find 24 squared. And 24 is 24 squared is 576 pi. That would, if we wanted it in terms of pi, we would leave it like that. If we wanted to, like, say, the nearest tenth, then we would say about 1,809.6. All right. So go ahead, you try that. All right, theorem 10.12, area of the sector of a circle. The area of a sector of a circle is the product of the ratio of the measurement of the arc divided by 360 times the area. So this is the same as for finding the length of an arc. All right, so if the measure of the arc is 60, and we divide that by 360, we get 1/6. So the area of the sector is 1/6 times pi r squared. If it's 120, that is 1/3, so we get 1/3 pi r squared. So we're going to use that. What is the area of the sector of RST? Leave your answer in terms of pi. So we're going to do the sector 84 out of 360 times pi r squared. And r is 9. And we want to leave it in terms of pi, so we're just going to simplify 84 over 360 as simple as we can get it. And that's 7/30. And then we're going to multiply that by 9 squared, which is 81, and by pi, and simplify that as much as we can. And that gives us 189 over 10 times pi. And if you want, it's okay with me if you make that 18.9 pi. All right, I'll let you try that. All right, the area of the segment is the difference of the area of the sector and the area of the triangle formed by the radii and the segment joining the endpoints. So if we take the area of the sector minus the area of the triangle, we get the area of the segment. So this is the segment right there. So what we need to do here is take the area of this 90-degree sector right there. Let's just write that down, area of sector minus the area of the triangle. All right, so the area of the sector, we're going to get that by doing 90 divided by 360, which is 1/4, times pi times 7 squared. The area of the triangle is, that's not a right triangle, so the base is 7 and the height would be the same. That's the other radius. So 1/2 base times height. And so we get 49 pi over divided by 4 minus 49 over 2. And that equals, we're supposed to round our answer to the nearest 10th. To the nearest 10th, we're going to say it's 14.0. All right, I'm going to let you try that. All right, let's check. Suppose sector in circle P has the same area as sector in circle O. Can you conclude that circle P and circle O have the same area? Explain. Use the figures at right. So find the area of sector AOC in O. So to do that, we're going to do 45 divided by 360, which is 1/8 times pi r squared. And if we simplify that, we get 64 divided by 8 is 8 pi. And then we're going to do the other smaller circle. In that one, we have 180 divided by 360, which is 1/2 times pi r squared, which is 1/2 of 16 is 8 pi. And do the sectors have the same area? Yes, they do. Can you conclude that circles have the same area? No, you can't. Because obviously you can have the same, you can find some sector of a circle fit at almost any area. So if they have a bigger sector, then they'll have a bigger area. All right, that's the end of the lesson. I'll see you tomorrow.